Hello everyone, glad to see you. Today we would like to talk about straightness. Straightness is 2D version of flatness. Straightness can be used for surface, for axis, midline. Let's see the first example. The straightness symbol is this line as it is mentioned here. This straightness refers to this surface. It means for each line on this surface in the mentioned direction, this wavy shape can be changed in this interval 0.2 as we can see here. And also here we have this straightness for the same surface but in another direction. It is 0.1. We can see here these wavy lines can be changed in the mentioned tolerance zone as we can see here, 0.1. Whenever we are going to implementing for the pin, as we can see here in this example, it is 0.1. It means this very wavy surface, this up and down, can be changed in the mentioned tolerance zone. As we can see in this figure, both of them, this symbol and this symbol is going to refer to this surface. We are going to control the shape of this component. We are going to talk about the form. We don't need to use any datum feature. So far, we have talked about this symbol. When we have a straightness and we have one number here, it means for whole surface, for each line in the mentioned direction, we are going to use this tolerance zone 0.3. But whenever we have this symbol here, a straightness, and two numbers here in this manner, we can see for each 10 mm, we are going to have this tolerance zone for straightness. Let's see this example. This straightness symbol is connected to the dimension. It means we are going to talk about the midline between these two lines for different cross section. Here, for example, for this cross section, we are going to measure what is the midline for that, and this midline can be vary based on the straightness in this tolerance zone 0.02. For another cross section, again we are going to measure where is the midline, and that midline should vary in the mentioned tolerance zone for the straightness. Here we have add modifier MMC. It means we should have the smallest value of the gap to have the MMC. For MMCs, we have this tolerance zone. For other values of the gap, we are going to calculate what is the tolerance zone for that, as we can see in the green color. Again, when we have LMC, least material exists on component, we need to have this value, the biggest value for the gap, to have LMC. For that situation, we have this tolerance zone. For other values of the gap, again, we are going to calculate what is the tolerance zone for the straightness. It is mentioned in red color, the last column. Here, the straightness is implemented for this surface, for this pin, let's say, and it is 0.5. It means 0.25 up, 0.25 down. This shape can be concave, convex, or can be vase or barrel, as is highlighted in this slide. The straightness of this pin is going to control this up and down, this concave, convex, this shape of this pin. It should be in the mentioned tolerance zone for the straightness. In the last slide, I'm going to mention the straightness of the axis. As we can see, this straightness symbol is connected to the dimension. It means we are going to talk about the axis of this pin. The axis of this pin can be varied through this cylinder with dimension diameter for the straightness here, and in this manner mainly we are going to control the bending of the pin, as we can see here. In the second example, it's connected to the dimension. It means we are going to talk about the axis of the pin. We are going to have a cylinder with diameter of 0.05, and the axis of the pin can be changed in this cylinder. Now I would like to close this session. In coming session, I'm going to talk about the axis when we have a straightness for axis when we have the modifier. Thank you for today. I hope you enjoy it.